Welcome, everyone. It's good to see so many people in Canberra, in the old Young Stars meeting place, as well as joining us online. And today we're going to be talking about Mars, a little bit about the history of Mars. And of course, the hot topic, as is always, is there life on Mars and if we can actually find it. So we already talked a little bit about everyone in the Young Stars team. So here's everyone's faces. I think we missed out Tim before, who helps us behind the scenes now because he's in Europe and he's asleep right now. But while I'm going through this talk, I'll keep an eye on the Zoom chat. So anyone on Zoom that has questions, feel free to send them through and I'll try and answer them along the way. And then at the end, we'll focus more on the people joining us from Canberra. But to begin with, I've got a question for everyone. Have you seen Mars before? Through a telescope, perhaps? Has anyone looked through a telescope to see Mars? So some people on Zoom are saying yes. Some are no. How about in person, James? How many people there in Canberra have seen Mars through a telescope?
I think about 10% of the people here joining us have seen Mars through a telescope before.
Awesome. That's a few, but still a lot of people that have that will still have their first time to see Mars through a telescope. And those in Canberra can go along to the Mount Stromlo Open Nights to do just that. But if you're not in Canberra, or if you're just around the place, if you look up at the night sky tonight, this is more or less where you'll see Mars in the sky. If you look kind of towards the northwest, it'll be near to the moon, and it will look like kind of an orange point floating in the sky. And through a telescope, Mars doesn't look too great. It kind of looks a bit boring, to be honest. And through the very earliest telescopes, it looked very boring indeed. So telescopes have been around for a while now, and one of the first images we have of an astronomer was taken in 1659 by Christian Huygens, who, with a 40-meter long telescope, pointed it towards various things. And one of those things was Mars. And because there were no cameras back then, he had to try and draw what he saw. So looking through his 40-meter telescope, which we can see here on the left, a rather bizarre-looking contraption. So this kind of black smudge, which almost looks a little bit like Africa. Other times he would see this other weird smudge, and some other times he would see another smudge. So all of these different smudges are, of course, of Mars, because Mars is a planet and planets tend to rotate. So if he looked at Mars at different times, he would see different parts of Mars. So all of this is pretty rubbish, really. If you were to look at these images and try and work out what Mars is and what's interesting on Mars, or even the question of if there's life on Mars, you would have no hope of answering any of those questions because there's just pretty much no information there. But after many years progressed, if we jump from 1659 all the way to 1893, we see this picture of Mars has emerged. So telescopes have improved dramatically over the course of that time. We go from that very weird long 40-meter telescope to this one here that Percival Lowell made. But people were still looking through telescopes with their eyes. And one of the things that people started seeing on Mars were these things they called canals, these kind of straight lines that stretched across Mars's surface. And they started dreaming about what these straight lines could mean. There was one Italian astronomer who described them as canale, or lines through Mars. So, a bad translation later, a lot of English astronomers thought that this meant canals, man-made or intelligent creature made canals across the surface of Mars. So emerged this idea that there were intelligent aliens on the surface of Mars that made big cities all across the face of Mars. And then they started thinking of why these intelligent creatures would be making canals across the surface of Mars. Does anyone have any guesses as to why someone would want to make big canals everywhere? On Zoom chat, there's water and life.
Mm.
What do people in Canberra say?
So maybe I'll go right here.
Just for transportation.
Yep, transportation.
Transportation. We had some people
can
on Zoom
drive
suggesting that as
boats
well.
and cars through the canals. Where else? Over here. That's right. So maybe moving water from the poles to different cities across the planet.
Yeah, so a lot of people, it sounds like in
We're moving
person, have the right ideas. Any more ideas from in person?
Well, there are lots of ideas, but maybe we'll take one more. We'll take one more. Yeah, so they could just be natural rivers.
That's a very good idea. So it could have been natural. You're very right there. There's no reason from what they've seen to suggest it's unnatural. But the astronomers of the time were pretty biased in their thinking. They thought any structure like this had to be unnatural. And I see a lot of people on Zoom have had the same idea that these straight lines, these canals, would be used to transport water from areas where they expected there to be water, like the poles, towards their cities so that they could water themselves and survive. So if we overlay this map of a canal Mars on top of a modern image of Mars, a few hundred years later, we see something kind of interesting. We see on the right Mars, of course, it looks nothing like those canals that we saw before. In fact, I don't see any straight lines across the surface at all. And in some ways, I kind of see perhaps an Africa-shaped thing like Christian Huygens suggested might be on the surface of Mars. So it's interesting in some ways that a very old 40-meter-long telescope did better than fancy telescopes in the late 1800s. But what we can see is that these areas where they think there are canals don't seem to have much going on, but these dark patches seem to be quite correct. And then you have the pole, which is covered in some ice cap. So the idea, people have now tried to work out why all of these prominent astronomers, which could observe things pretty accurately for the most part, why they were saying that there were canals on the surface of Mars. And I think the leading explanation is that they were actually seeing the veins in their own eyes. So Mars is bright enough that the projection of light from Mars can light up your eyes and light up the veins around your eyes, so that they were actually seeing these straight networks of their own bodies instead of stuff that's on Mars. So this was a big misadventure in science. People were fooling themselves. Sometimes this happens. We get confused and we think along the wrong line of thought. But eventually, with better instruments, things that didn't have veins in them, we saw that Mars did not have canals over it. So it didn't have this intelligent civilization that we had perhaps been thinking that was there. So I guess that's a bit unfortunate in that case. But after learning that Mars was perhaps more boring than we'd hoped, that was when the space race really was kicking off, and there was missions to the Red Planet. So this was one of the first missions to Mars, Mariner 4, which launched in the 1960s. And you can see this was before we had really good images of Mars, because this artist impression of what Mars should look like looks nothing like we saw just before in this image here. So this one is jumping forward a few years, this image on the right. But what Mariner 4 did is it flew by Mars. It didn't stop by in orbit. It just went on past. And as it flew past Mars, it took a bunch of pictures. And those pictures were pretty rubbish by today's standards. We could see a few things like craters here and there, but nothing too substantial. Our first real understanding of what Mars was like came to us from the Viking probe and landers, which were these fun things here. So this top part is the Viking orbiter. So this would orbit around Mars and take very detailed images. And this little thing down here is one of the Viking landers. So this would enter into Mars's atmosphere and land on the Martian surface. And the thing that would land on the Martian surface isn't small like it might appear in this image, but actually the size of a person. So here we have a famous astronomer, Carl Sagan, standing next to the Viking Lander. And what we find is that this thing is quite big. And on the surface of Mars, the Viking Lander would go about doing various experiments to see if there was microbial life on Mars, and just generally finding out what Mars was like. But unfortunately, the experiments to find life on Mars proved to be unsuccessful. So in this case, we didn't find any Martian aliens. But what we did find with the Vikings was some really interesting pictures. So as the orbiters went around Mars, they took very detailed images of the Martian surface. And this is one of those images. So it's quite interesting. We have craters like we saw before, but there are some other features. And does anyone have any guesses as to what could have caused these features? So anyone in person or here on Zoom? Impacts. So things storm, that's a good idea. So what about this thing? What does it look like? Any ideas from in person?
We have lots of ideas in person.
Mm-hmm.
So let me get around to some of them. One very inclusive one here.
Comets and asteroids.
Comets and asteroids. So comets and asteroids coming in, smacking into Mars.
Yeah, so those, a lot of ideas like that in Zoom as well. So these would make these dents. What else? What is the stuff around the crater kind of look like?
Yeah, so some lava flow, actually volcanic activity on Mars.
That's a good idea.
Causing these kind of teardrop shapes. So maybe ice freezing into these weird teardrop shaped structures. So some kind of flow. So we're thinking that the teardrops are associated with some kind of flowing material, which could be a river, could be from a volcano, something like that.
Yeah.
Maybe one more at the back here. Yeah, so we're thinking it's some kind of water flow that is pulling the structures along with it and causing these teardrop shapes.
Yeah, that's exactly right. So this is what a bunch of physicists and astronomers that were looking over this data came to the same conclusion. They thought, well, you could only have this kind of structure if there was flowing liquids that went from, say, the bottom left-hand side of this image up to the top right-hand side of this image. And this kind of structure, I heard someone in Canberra mention erosion. This is a feature that's made through the erosion process. So you have to have water flowing for a long amount of time. So this kind of hints to the idea that Mars once had flowing water on its surface. It wasn't always this red ball that we see it today. And if we stitch together all of the Viking images for one side of Mars, we see it looks quite awesome. This red planet is not quite as boring as people thought it was early on. It has lots of really interesting features. This big thing stretching through the middle, which I'll put a red circle around now, is something called Valles Marineris, and that's a rift valley that's 5,000 kilometers long. It's so long that even the Grand Canyon, which is the biggest valley on Earth, or the biggest canyon, can fit inside of one of these tiny little arms. So it's absolutely enormous, and it shows us that Mars had some pretty dynamic things that happened in the past. And likewise, off to the side of this image are a few little things poking out of Mars's surface. So this area is known as the Tharsis Plateau, and these things poking out of Mars's surface are the great extinct volcanoes of Mars. So Mars has the biggest volcano or volcanic structure in the solar system, something called Olympus Mons, which is so big it actually changed how Mars spins around, how the days on Mars works. Can everyone hear me again?
Yes.
We can hear you, Ryan.
Yes.
Okay, good. Turns out New Zealand internet isn't so great sometimes.
Yes.
Let me get set back up again. Sorry about this.
And also, while you're getting set up, we had a question in the Canberrian mission control.
Yep.
So the question was about debris. So if Mars was hit by a lot of impacts, how would the debris from all of the impacts distribute themselves around Mars? Yeah, so you hit Mars with an asteroid, and then Mars has a water system. How does that debris move with the water system, I think is the question.
Right. Yeah, that's a very good question. So one of the ways, that they actually determine the age of all of these water features is actually based off where asteroid impacts or where impact craters are. Because in general, we have a fairly good understanding of the periods of time in our solar system's history when there were lots of impacts. So if we see some kind of water-like river feature with an impact sitting on top of it, then we can say that the river stopped running after or before the asteroid impacted. But if we see those impact craters from before with these teardrops, we can say that this was impacted while the river was still running. So this idea of using impact craters to understand the history of Mars in terms of the liquid is actually a very good idea. And it's something that scientists use all the time. So hopefully that answers your question there. So getting back to where I left off, what I was going to say is that we've sent lots of robots to the surface of Mars. So the Vikings were just the first step. The next thing that was sent were the Curiosity rover, which is quite a big machine. It's about the size of a van, and it roved around the surface of Mars, collecting lots of really cool bits of information. And all of the information it collected pointed again towards the idea that Mars once was a very watery world. So the image emerged that Mars, once upon a time, looked a lot like this, where it would have had clouds of water and it would have had a big ocean across its surface. All of this ocean now is gone. We don't see it. And part of that is because most of Mars's atmosphere has been blown away by the sun. And it also seems like a lot of the water of Mars, after the atmosphere disappeared, kind of seeped into the crust and froze. So we don't really see it anymore. But because Mars had lots of craters around the place, you would have had really cool things like these crater lakes. So this is the Azero crater about 3.7 billion years ago, or how we think it would have looked. So you have these rivers that feed into the crater and make it a nice place for perhaps life might like to call home. And since there are rivers going into this crater, you have some really cool geology going on. So this is again an elevation map where blue and purple is lower and white and red is higher. So you can see here are the rivers feeding into the crater. And if we zoom in to one part of this, we can see a feature here that we call a river delta. And these river deltas are what happens to the sediments of all of the stuff that gets eroded further upstream. It all gets deposited in these river deltas. And more often than not, these deltas are made of kind of a clay-like substance. And on Earth, they're very good at preserving evidence of life. So if you were interested in trying to understand the history of Mars in this period of time, about 3.5 to 3.7 billion years ago, when Mars had water on its surface, then you would want to send a rover to the surface of Mars to look around here to try and find evidence of that life, whether it was there or not. So you might have heard of the new rover that's just landed on Mars recently, and it looks an awful lot like Curiosity. In fact, it's almost identical to Curiosity. It's just been upgraded in some ways. This is called Perseverance. And Perseverance has the very awesome mission of trying to find evidence for old life on Mars. And unlike Curiosity, Perseverance had videos of how it landed on Mars. So let's just take a moment, and I'll skip through some of it, but let's look at the stream for how Perseverance landed on Mars.
Just before you play, Ryan. Just before you
What was
play,
that,
Ryan.
James?
Just before you play, who's seen this already? Oh, lots of people. This is really, really cool. So everyone pay attention here. This is so awesome. This is humans being the best humans possible. Landing something on Mars with a sky crane. A sky crane. It's crazy.
Yeah, it's super impressive. So this is the second time that they've done it. The first time was with Curiosity, but they didn't have cameras on Curiosity to record it. But this time they learnt from their mistake there, and they put lots of cameras all over Perseverance. Let's try and skip ahead to the exciting parts. So, oh, that's too far. So the first thing it does is it fires out its parachute, and this parachute will slow down the capsule quite a lot. So it will go much slower. And there's actually a message encoded in the parachute, which you might want to look up later. So at this point, they're dropping something called the heat shield. So this big thing there was what took up all of the energy of the probe slamming into Mars's atmosphere. So now that just drops down to the surface of Mars. And hopefully it doesn't hit anyone down below. So now Perseverance will just kind of drift gently down. It's still traveling pretty quickly, I think on the order of tens of kilometers per second. Oh no, wrong. 3.3 meters per second. So the parachute does a great job at slowing Perseverance down, but it's not enough to actually slow it down completely. If it were to land on Mars right now, it would be smashed to pieces. So that wouldn't be a very good use of money.
What is it?
So what they said there was that all of the computers on Perseverance had analyzed the surface of Mars and had determined where it should put the lander down. So all of this is done autonomously. It's about 7 minutes. This happens, and then we receive the signal that it happens about 7 minutes later.
So the computers on board this rover had to make all the decisions right now. These aren't humans controlling these things. This is the computer trying to work out where to land, try to work out what the best time for all these deployments are, everything. So this is what you do when you go to science and engineering.
So the sky crane's gonna start down now.
And have sites over it. It's like it's going
Yeah, they've mapped it well.
around it. You have to now we're getting orders.
So this part's absolutely crazy, right? They dangle down the rover, which weighs a ton or so, and just kind of hang it beneath this thing on the top left. And that fires its thrusters and slowly lowers Perseverance down to the surface of Mars.
That's the sky crane right there. And now the sky crane has dropped the rover and it's just taken off.
Yeah,
From the
it's
other
the
one?
atmosphere.
And that's a very happy.
So
engineers.
that's an awesome display of what people can achieve when they work together and do take on very hard challenges, but persevere to make sure that those challenges are fulfilled. So if we go back to that elevation map we had before, here is the Azero crater, and this is the delta that we talked about. So the projected landing area for Perseverance was more or less this red oval here, and where Perseverance landed was about where this orange star is. So they landed perfectly within their projected region to land, which is phenomenal. They fire this from the Earth, and once it's left the Earth, they have no control over what happens. It's all down to the machinery and the computer programs that they've developed to land in that spot. Because as we mentioned, it took 7 minutes for us to find out what actually happened. And there's lots of really cool videos of this stuff landing. So what was this one? This one is the heat shield as it plummets down to the surface of Mars. So look at all of this awesome detail we can see of the delta. And these are just kind of useless images, but they serve a great scientific use as well, because we can find out some more geological ideas from what's going on. Okay, so what makes Perseverance interesting? Some of the things that make Perseverance interesting are in this big arm here. So the part we can see, this part with the red circle, is a core sampling drill. And this drill will drill into the surface of Mars and take little core samples that they can analyze and they can pack up into little sample canisters. And the other thing that they're going to do with these sample canisters is try and return them to the Earth at some point. So this is another video. We won't watch all of it though. This is just how the core sampling arm works. So it will lower its big arm down to the surface. Very carefully. You don't want to slam all of this expensive equipment down. So they'll drill into some rocks and they'll bore out a little core. And then that core gets passed into the rover. So all of this is happening autonomously inside the rover. It's handling the sample all by itself. Okay, so it does all of that very important bookkeeping stuff. And then, where is it? Yeah, so after it's done that, it'll drop that sample off and then drive away. With the idea being that sometime in the future, another mission will come along and pick up those core samples, and they will be shot off into space on a rocket, so that one day we'll be able to see them again on the Earth. The other cool thing that they have on this arm is this white box here. This is the pixel camera. And this is cool because they're going to be using it to try and see evidence of fossilized life on Mars, or evidence of past life on Mars. And they do this with a very sensitive camera, which can determine different materials and different compositions. So this is just a few test images they had of different structures. So you can see that they glow differently in different images, and they're able to determine from these images what's actually going on. So the thing that may find life or evidence of life first on Mars is this little camera here, this pixel camera. If not that, then hopefully, if there is life to be found, it will be in the core samples that eventually get returned. But the other thing that Perseverance has, which is really unique and really exciting, is a helicopter. And this helicopter will be launched or have its test flight in about 3 days. So let's get forward a bit. So it's carrying it within it. It'll drop off the helicopter, drive away. The helicopter called Ingenuity. Once it gets to a safe distance, of course, you don't want the helicopter crashing into your expensive rover.
Don't want expensive stuff crashing into expensive stuff.
What a good use of money.
So there's very little atmosphere on Mars, so building a helicopter that can fly in the very tenuous Martian atmosphere is a really hard thing to do. So it has a counter-rotating design where one propeller spins one way and the other spins the other. That stops the little helicopter from spinning out of control. And it's planned to be solar powered.
That's all.
So the main objective for this is just to show that you can fly a helicopter on Mars. And while it's on its flight, it'll hopefully be taking pictures, which can send to Perseverance. And we can perhaps see if there are interesting things that Perseverance should go and check out. So it's kind of like a little scout for Perseverance if it works, though we don't know yet if it will. So this is a simulation of what they expect it to be able to do. So like Perseverance, how it landed on the surface of Mars with the sky crane, Ingenuity has to also work out where it can land safely on the surface of Mars. So there's lots of really hard challenges that they've had to overcome doing this. Okay, so this thing, if you're interested in watching its first test flight live, we'll be doing it in the next 3 days. When exactly is that? It is on the 24th at 4:30 a.m. Australian Eastern Daylight Time. So if you want to get up super early and watch that, then that's something that might be pretty fun to do. But this is our new experiment to try and find evidence of life on Mars. We haven't found evidence yet, but this, I think, is our best bet so far for finding life there. So let's see if people have questions now, and we'll try and answer everything that we can.